Sean, did you get to watch the notes last night?
I did.
We mentioned you many times, so yeah, excellent.
Yeah, tell us what you said. Tell us exactly what we said so we know you watched it.
Yeah, how do you know that? How do we know you watched it?
Well, I heard Seth's discussion.
Ah, okay, then we're good. All right, you definitely watched it. That's what I was waiting for.
Yeah.
I was like, if you say something about Seth,
I did.
you got it. Yes.
Oh, that was really quick.
The answer, like that was just like boom, really quick.
That's how you know there's something.
Because it came up.
Oh no.
It started off real low. Luckily, we worked our way up.
Oh no.
I know. Yeah. Jake helps.
Okay, I didn't say anything.
Yeah,
So
I know. That's what I know. I was starting to.
I kept to the code. All right, whatever the code is.
I just sat there and watched the whole scenario.
Who brought it up?
Well, I had like sort of brought it up like to Sophia yesterday. Not like I didn't bring it. I was like, Sophia, we talked about you and Chem, but then I was like trying to like just say why, and then I just kind of fell apart. So I was like, I'll wait till lunch and let Jake and Trey be there. Jake will be good at explaining.
Okay.
And then I was like, because if it's a controlled environment, if it was just me, I would have just fighting myself.
Exactly. Right. Yeah.
You would have been the weak one and she would have been the strong one.
Yeah.
Right. As long as you're the weak one, it'll work out.
That's right. Yeah.
It'll work out. Okay. So yesterday we left off at this point. We were talking about strong bases, strong acids. We talked about taking a P, right? Because when you take a P, you're taking a negative log. So I have let's write out a quick equation here. So if we have NaOH, which is going to be AQ plus water, which is going to be a liquid. By the way, do we include liquids in equilibrium? No, we don't. All right? That is going to break up into what? What is this going to break up to? Yes. OH minus. So those are ions in solution. Plus Na plus in solution. Plus
What?
still H2O. Right?
How?
Wow. What do you mean how?
No, I don't know.
It completely dissociates, right? It completely dissociates. So
H2O just doesn't break up.
H2O is just still liquid, right? Which is how you do a net ionic equation too, right? It doesn't break up.
Okay,
It stays together.
I was thinking we were gonna have like the OH.
So if I have 0.01 molar of this, what is my molarity of OH minus? It's 0.01 molar. You got it. So I'm just showing you that whatever, if it's a strong acid, strong base, you got it. It works for an acid as well. So I have HNO3 plus H2O. That is going to give me what? HNO3 plus H2O is going to be a little bit different. Hydronium, H3O plus what? NO3 minus. So strong acid completely dissociates, but on this one, it's going to rip off that hydrogen. The hydrogen is going to go with water. So if I start out with 0.01 molar of HNO3, what's my molarity of H3O plus going to be? It's 0.01 molar. You got it. So it's the same. So since we know the concentrations of OH and H3O plus, we can take AP directly. Or we could also use that standard conditions 14, right, actually equals, this is going to blow your mind, pH plus POH. If you add them together, that should add up to 14, which is the pH scale. So the highest number on the pH scale is 14. pH plus POH should add up to 14. Brendan.
On the last reaction you wrote,
Yeah.
how come we are using the actual hydronium instead of just H plus?
It's either one. You could literally just write H plus here.
So you could still write H plus.
Yeah. I'm going to stop writing hydronium out eventually, okay?
I just like,
H3O plus, H plus, same thing.
I just don't know when is the right one.
They're both right. They're both right.
Is there no difference between H3 plus?
No. It's the same. H3O plus, hydronium, same. H3O plus, H plus, interchangeable. We don't care about the rest of that. We just care about the hydrogen
There's
con.
gotta be an except, right? The interchangeable except for.
I don't think so. I can't think of an except. I know.
That's the one.
Till next chapter. No. All right. So, what is the pH of the solution? What is the pOH of the solution? So, if I want to get the pH of the solution, let's do pH. We know that pH is equal to the negative log of the concentration of H plus. So this is going to be in the negative log of 0.01 molar. So do that in your calculator now. So take the negative log of 0.01 molar. Negative log of 0.01 is what? 2. So my pH equals 2, and my pOH is going to be the same, right? Also negative log of 0.01. So it's going to be also 2. I don't know, I'm going to show it again, but let's do it. pOH is going to equal negative log, because I have 0.01 up here, of the concentration of hydroxide, which is going to be negative log of 0.01 molar, which is going to equal 2. So that's it. A negative log is taking a P. That is how you do it. Are you guys ready for this?
Now for another.
So, these here are not going to add up because I have NaOH and H2O. This was two separate equations. All right?
Couldn't they be less than 1 or more than 14?
Stay with me. All right? Stay with me. Next page.
I know when you're
And now, for another K.
No.
KW.
No more.
Guess what W stands for?
Water.
Water. You got it. So KW is the ionic product of water. Kind of exciting. So, pure water. We're talking about regular old pure water, H2O. How would you describe pure water? This is thinking back a couple chapters ago. Covalent. Pure water is covalent, but there is a small amount of self-ionization in the below example. But there is a small amount of self-ionization, comma. In the below example, we will write, and therefore, we will write pure water is essentially covalent. But there is a small amount of self-ionization in the below example.
Yes.
In the below example, we will write, comma, and therefore, it's fine. Just stay with me. It's an equilibrium constant, all right?
Therefore, it's a complex freaking.
Therefore, an equilibrium constant can be written. Pure water is essentially covalent, but there's a small amount of self-ionization in the below example we will write, and therefore an equilibrium constant can be written. I think that makes a little more sense.
Yeah.
It's a run-on sentence.
English class.
It's fine. So we have H2O, which is a liquid, plus H2O, which is a liquid. I know. H2O with a liquid, plus H2O, which is a liquid. What is that going to give me? H3O plus.
What?
H3O plus. Plus
OH
OH minus. How do we know that?
Because it's just H2O.
Because one of these has to be an acid, one has to be a base. Right? Because water can be both. Yes? Because one is going to be an acid, one's going to be a base. So one of these ripped off a hydrogen, one of them accepted a hydrogen. We have water and water, yes. But water is amphoteric. All right? Water is amphoteric. It can be an acid or a base. Brendan.
So you tell me if you have 2 water bottles and you pour them together.
No, I'm not.
It becomes something different.
So, no, I'm not saying that. All right? Is this going to happen in nature? No. All right? But I'm just showing you where this is derived from. All right? I'm showing you how this whole thing is derived. So if I'm gonna write, KW, KW is going to equal, and by the way, this would be AQ. This would be AQ. That's important. So KW for water is going to equal the concentration of H3O plus times the concentration of OH minus. I'm just trying to show you that the water is not part of it because it's a liquid. Oh, is that the? That was it. That was it. It's like I've heard now a couple times. So it's like a train. If you live by a train, eventually like you just like don't hear it anymore. So now I'm used to it.
You've gone sound blind.
Yeah, I've gone sound blind. I lived next to a train my freshman year of college, and the first couple weeks it's just like it would wake me up at night, and then you just.
I live nowhere near a train, and I still hear it.
Yeah, I still hear it.
What?
I don't.
No, I know what you mean. Sometimes you do like
It
that.
depends on the weather, though, right?
There's some.
Well, no, you don't even wake it
Okay,
up.
I live
You used to
like a mile north of Grace Church.
Uh-huh.
Oh, no railroads anywhere nearby. There's Woodville, and there's like 80.
No, up on Hutton, there's
I've heard a train.
there's a railroad that crosses Hutton. Hutton crosses a railroad.
I don't know, but I've heard a train.
If you're going Hutton towards 585, there's a railroad track.
Oh, that's true. Yeah.
Yeah, where was
So-
where was the train?
I don't know where the train was. I was nowhere near a train.
Okay,
I live next to it.
if we're talking about trains, let's really derail this conversation. There's multiple reasons. I said that. AP Environmental, have you guys talked about this big train derailment?
No, but I've heard so much about it.
Is it a cover-up?
Yeah.
I just think they're dumb for
It's always
voting.
a cover-up.
What are they
Is the government trying to cover up something here?
Probably.
I don't
It's
think
just
the
like
government is. I don't know what
it's
the
just
surprise
a
of the
problem.
railway company was.
Is the railway is somebody trying to cover up something here?
Cover it up with the $5 per person.
I just think the government's
What?
Like, yes, address it.
That'll really keep our mouth shut.
Abby?
Okay, just because we're on this topic, and I feel like it's an interesting fact about me. I'm terrified of trains, like
Okay.
terrified of trains. And I love my friends, like when we go over train tracks or whatever, but it's not funny story, but it's funny story. The only reason I'm terrified is anytime someone asks why, is because I keep having a reoccurring dream, or I always did when I was like 8, and it always ended with me being on like a railroad track, and then I woke up and I never knew the ending. Like I had like this dream like 6-7 times. So that's my fun.
You know how we can fix that? I know a psychic.
I've had a few dreams of trains too. It's like,
I'm
what's
terrified of
necessary?
trains.
It's like
I
the
know a
same
psychic.
thing.
I live in home by
Have you done it yet?
Yeah,
Oh, you did it?
I did.
Oh,
We
hold on.
Train runs over my family,
Let me
it's
pause.
barely on there.
Mr. Heller.
Yes.
He'll schedule the appointment.
Uh-huh.
I was in there, and he was talking about the college switch and stuff, and the card that he flipped was transformation, and the number on the card was 13, and I picked that for my number, and I've only ever been 15 or 25 my whole life. And then I
Where's
picked
this
number
psychic?
13,
Okay, that
and I was like, and that was the number on the card, and I was like,
that is
oh.
interesting.
Yeah.
How do you find this? Like,
Marathon, a good
They
one.
find-
Mary's got a good one. She has his card. So
You get like a discount if you refer a friend.
AP Chem all goes to the psychic. We all end up in therapy at the end of the year because of what the psychic has said.
We all know Mary Dixon.
Yes. Yes.
And if you
How was the
were
recession?
like,
I think he could.
like,
Like, but did he know before? Like, did he register your name that he could have like Googled you? I don't think so. It was all under my aunt's name.
Oh.
where,
See?
So your aunt knew a psychic.
are there like local
Yeah,
psychics
he
or?
knows a lot of psychics. It's kind of
What?
Wow.
Seems you're gonna be-
I will tell you this. When I was a child and I went to the Ohio State Fair, there was a big Smokey the Bear. And it knew my name.
What?
What?
Yeah.
Are you
Psychic
kidding?
smoking.
So like it's this huge animatronic Smokey the Bear. And he's like, "Hi Eric, how are you?"
I would have cried.
That's a
So
fun
Because a lot of people these days have to work 2 jobs
Yeah.
to get by. Is the psychic market drying up that you have to be Smokey the Bear?
I'm just saying. I'm just saying.
Oh my gosh.
Please don't ever run into a Smokey the Bear again. That's
No.
all I'm saying.
No, so like it's this big thing. I found out later that like there's people walking around and your parents whisper the name to the people.
Oh.
Yeah.
Oh, that would have been
So-
That's way less cool.
But that was the most magical moment of my life.
Magical, I would have been terrified.
I mean,
Somebody random, like, some
I'm
random
just saying.
person's name. See if they guess.
All right. So that was a good derailment all the way to psychics.
Yes.
Hopefully,
That is something I would.
I don't know.
Like, what kind
It
of a
happens.
place is this? Describe the environment.
It was mostly healing me in this like little room and like.
The Googling has begun.
He did not have a grip. Not one of those like.
It didn't have an orb? No orb?
I had to pay
Oh,
for
this is a
it.
well-rated
Of
psychic.
tarot
Yeah.
cards.
Oh, it's,
Oh, it was one of the cards one. I see.
Yeah, and then he was drawing the cards.
were there
and-
tea leaves?
Tea leaves?
No, but they sound like tea and like oils and stuff.
Where do you
so
get
they're
your
Average
really
psychic?
Okay.
I'm terrified.
All right.
Did you start the note?
Let's try to keep going.
Anyway, sorry.
I did restart them. So
I don't think
it's in the back of like a Chinese restaurant or something. Like, all right, are you here for the General So's or for the, you know? All right. As for back to K, KW. KW is going to. This one is actually going to depend on what though? Think about this. Temperature. It's going to depend on temperature. So at 298 Kelvin, KW is 1 times 10 to the negative 14th.
Whoa.
Now think about where we're going with this. Think about that number in terms of logs.
very small.
All right. Since pure water will have should have equal concentrations of H plus and OH minus, then under these conditions, concentration of H3O plus times the concentration of OH minus should equal 1 times 10 to the negative 14th, right? That means that the concentration of H plus should equal the concentration of OH minus, and these should both be 1.0 times 10 to the negative what? 7th molar. You got it. If you take a P of that, the negative log of the concentration means that the pH of pure water is 7. This means we can take a P of KW as well, and PKW, all right? Because we're going to start seeing like PKAs, PKWs, right? Is 14, which is pH plus POH. So, putting all of those K's together, KW equals 1 times 10 to the negative 14th, right?
Yeah.
Yes? Which also is going to equal Ka times Kb. And that's just an acid K or a basic K at different conditions. Either K at an acid condition or K at a basic condition. Or PKW. All right, so now we're getting the negative log is 14 equals pKa. What's the... It's going to be times Kb or plus PKb. You got it. So that kind of relates all of the K's together. So you can work in Ka, you can work in pKa, you can work in KW, you can work in PKW. And you're going to have to convert between these, is all there is to it. All right? So you're going to be taking negative logs, you're going to be getting it the other way. Opposite of a negative log is, I have to think about that. 10 to the power. Yeah, 10 to the negative power. So you're going to be doing the negative logs. Yes, I think that's right.
10 to the reciprocal.
Yeah, that'd be the negative power. I believe so.
Yeah.
Yeah, to the negative power. So here we go. Let's do a little bit of practice. Calculate the pH of a solution of 0.030 molar hydrochloric acid. Number 1, is hydrochloric acid a strong acid?
Yes.
Which means it does what?
Fully dissociates.
Completely dissociates. So I can assume if I have 0.030 molar hydrochloric acid, what is my concentration of H plus? So take a negative log. So the negative log of 0.030 equals what? So take the negative log of 0.03.
Jake will get past it.
1.5. So number 1 is 1.5. Number 2, calculate the pH of a 0.01 molar solution of lithium hydroxide. Is lithium hydroxide a strong base? Yes. So I can assume if I have 0.01 molar of LiOH, I have 0.01 molar what? OH. So the negative log of 0.010 is equal to what? 2. And that is equal to my POH. But it didn't ask for the POH, it asked for the pH. So I know that 14 equals pH plus POH, right? Yes?
Yeah.
So pH equals what? 12. Done. So if you have the POH, you can very easily get the pH. So many times they'll give it to you as a base. You'll figure out POH, have to subtract to get to the pH. Number three, calculate the concentration of H3O plus in a solution. Now we're going to work backwards. Of a pH of 4.32. So I have to do 10 to the negative 4.32 to the negative 4.32. And what do you get for that? I had 4.8 times 10 to the negative fifth. I guess with sig-digs it would have been 4.79. So 4.79. So we're just working these backwards or forwards is what it comes down to. And then number 4, calculate the pH of a solution made by dissolving 2 grams of KOH in H2O to a total volume of 250 milliliters. What is step 1 going to be?
Moles.
I need moles, right? Yes. So I'm going to take my 2.00 grams of KOH. Molar mass of KOH is 56.1. So 56.1 grams of KOH in 1 mole of KOH. So I'm going to solve for moles of KOH. Do that. Were you guys here last week when the bell rang different?
Yes, that threw me off.
That was the bell from my high school.
No.
When I went to Worcester High School, like all of a sudden, I was standing right by that desk behind Vince, which is where I sat in this room
No.
in the year 2002
I would have gotten like
and the year
flashbacks.
2003, and I was standing right there, and then it hit, and I'm like, whoa, like crazy. That was the bell. Yeah, that was the bell from my high school.
It's like in the 70s.
Because it's like boo, boo. It was like that. That's how the bell was. Because this bell that's ringing is actually the minute bell from when I was in high school. It used to be there was a minute bell before every parent would go boo, boo, boo,
I
boo,
think there
boo.
still is one.
Yeah, but it's the same.
I know, you can
And then it
never
would go
tell.
boo, boo. Like yeah.
You can never tell.
It was weird. It was very weird for me.
You do like cards or.
How many moles of KOH did you get?
0.0357.
0.0357 moles KOH divided by
molarity. So 0.205.
divided by 0.250 liters because I need a concentration here, right?
Yeah.
C.
So I need to get my molarity, and what does that give me?
Oh, shoot. No. Not wrong.
I got 0.14 molar KOH, and now I need to take a P. So the negative log of 0.14 equals, I got 0.85, which is equal to POH, but it's asking for the pH.
Oh, this is where you get the.
So pH equals 13.15. So, a lot you can do there. A lot you can do there. Do you have the hiccups?
No.
I call that the hiccups sometimes.
I sneezed and Brendan made fun of me and did what I did right after that.
Oh.
Does the psychic say bless you before you sneeze?
Ooh.
Yes, dude. That would be awesome.
You gotta sneeze next time. I'm really sorry.
Flip it. So, I alluded to this yesterday, right? I alluded to this yesterday. What we just did was all for strong. Was all for strong acids and bases, which strong acids and bases completely dissociate. Weak acids don't do that, so we have to use ice. We have to use ice. So you're always hoping to you're always hoping to get the pH of a strong acid, right? So much easier. But we know how to do this.
100%.
So in a weak acid, HA, dissociation is incomplete. Dissociation is incomplete. So the equilibrium is set up, it would look something like this for a weak acid. So I have HA which is going to be AQ plus what? Water, which is liquid, is going to be in equilibrium with H3O plus A minus. So I have AQ, AQ. Do I really care that much about A minus?
No.
No, what am I trying to figure out? I'm trying to figure out the concentration of this, right? Yes? So I would have something like this. I'd have initial. So this is going to be X. There's never water. 0, 0. My change is going to be minus X, nothing, plus X, right? So my equilibrium would be like X minus X, nothing, X and X. Just kind of showing you the work, right? You would have real numbers in real life. That's what we're going to be doing. You guys know how to do that. You should know how to do that. Now, obviously there could be 2x, there could be other stuff here, just like last chapter. So in this case, we have no clue how much acid or base is dissociated. How much is dissociated? So it's not possible to directly take a P. It's not possible to directly take a P, negative log, from the concentration of the acid. From the concentration of the acid. So since the acid is weak and there's very little dissociation, then my Ka must be very what?
Low.
Small, right? Because it's not shifting very far to the right. So the x minus x means the little x is almost always going to equal what?
0.
Yes, 0, which Allison still hates. We also know the concentration of hydronium and OH must be equal. And H2O liquid is a pure liquid, so it's not going to appear in the Ka expression. So we can write any of the following. We could say Ka equals concentration of H3O plus times the concentration of just A minus over the concentration of HA. That'd be one way to write it. Or I could say that Ka is equal to concentration of H3O plus squared over the concentration of HA, because these should be the same. Or I could say concentration of H plus squared over HA, or X squared over X. So a lot of different ways to write that. But the main thing is to know that you're only going to have one thing on the bottom. And pKa still equals the negative log of Ka. So the pKa means I've taken a p, so it is the negative log. So here we go. Practice with these. If ethanoic acid, which is a weak acid, has a pKa of 4.74, what is the Ka?
10 times negative
10 to the negative 4.74. So you have to know, if it's in the p version, I've got to get it out of the p version, so it's going to be 10 to the negative power. So 10 to the negative 4.74 is what? 1.82 times 10 to the negative what?
6.
I have fifth.
That makes sense.
Okay. As long as Jacob says.
Yeah.
All right. Jacob says that makes sense. It's also the right answer. If propanoic acid has a Ka of 1.38 times 10 to the negative fifth, what is the pKa? So now I have to take the negative log. Just doing some easy practice here. So the negative log of 1.38 times 10 to the negative fifth is
4.79.
Huh? I had 4.86. I had 4.86. You said 4.79 or something.
Oh, I was just talking to myself and then I got out 4.9. I was trying to do.
Got it. Which version of yourself were you talking to?
He's so focused on the psychic thing.
I was talking about the psychic version. Like, is this like a past life you, current life you?
This was past me.
Got it. Which is a stronger acid?
I think you're gonna guess wrong.
Which is a stronger acid? Ethanoic. Why? Ethanoic, which one has the larger Ka? Hold on. Ethanoic, because, no,
What?
hold on. Ethanoic.
The larger pKa or Ka?
Ethanoic has the largest Ka, agreed?
Yeah.
Yes? Ethanoic, because it has the largest Ka. Think about that, right? If the largest Ka, the largest K has the most what on the top? The most products, which means more dissociated. So the larger the Ka, the stronger the acid. The larger the Kb, the stronger the base. Because to get a larger K, you have to have more products than reactants.
So could you also say the lowest?
You could also say the lowest. PK, that would work too. Either one. But we usually just compare Ks. Either way. You could say the lowest pKa too. Same thing. Yes? Ethanoic because the largest Ka. So more dissociates. So more dissociates, more ionizes. Because we know a larger K means I have more products than reactants. Okay, what is the pH of a 1 molar solution of ethanoic acid? Gotta ice it.
We can't just take the P of it?
No, because it's a weak acid. We don't know how much is going to H+.
Weak acid?
Yeah. Is this one of the 6 acids you have memorized?
Sure.
No.
Then it's a weak acid,
That's all we need.
right?
You just gotta memorize this.
You gotta memorize them. You gotta memorize them. So here we go. Number 4. Let's set up our R first. My reaction is CH3. Did I give this to you anywhere?
No.
Okay, well, I'll just tell you what it is. CH3COOH. That's ethanoic acid. AQ plus H2O liquid is in equilibrium with H plus CH3COO minus AQ. So notice I did not write hydronium that time because it's the same thing. It's the same thing. Initial. What's my initial concentration? 1.0 molar. Water's not part of this. 0 and 0. Because until I put it in water, nothing's going to dissociate. Change. Minus X. Not part of it. Plus X. Plus X. So equilibrium is 1 minus X, X, and X. So if I'm going to substitute this into my Ka, I know that Ka is up here. It's 1.8, right? Yes. So 1.82 times 10 to the negative 5th is going to equal what? X squared over what?
1.
So it's just equal to x squared. So this math gets easy, right? The math gets easy because this 1 minus x, the x goes to 0, x squared divided by 1. I don't even have to write that. So what does x equal?
4.27 times 10 to the negative.
I got 0.00427. But I don't want the concentration of H+. I want to know the pH. Take a P. So the negative log of 0.00427 equals what? 2.37. So that is the pH. So when you have a weak acid, you have to do more work. Number 5. Number 5. Yeah. Weak, strong. Conjugate, you're going to have the conjugate relationship, right? 5. Calculate the Ka value of a 0.100 molar solution of a weak acid with a H plus concentration of 1.75 times 10 to the negative 3rd. So, if you're thinking about these up here, right? I can kind of skip to basically this step. I can skip right to this step because I know all of the things. So number 5, I know that Ka is going to equal concentration of H plus squared over what?
HA 1.10
And HA is the 0.100 molar, right? Over 0.100 molar. Substitute in. My H plus is 1.75 times 10 to the negative third molar, that whole thing, squared divided by 0.100 molar. That is going to give you your Ka. What do you get? That's what I had. I had 3.06 times 10 to the negative fifth. And then number 6, I have barely enough room, but I'm going to write it here. I think I can fit it. Calculate the Ka of a solution that is a 0.250 molar of a weak acid with a pH of 5.11. What's my first step here? 10 to the negative 5.11. So 10 to the negative 5.11 is going to equal
7.76 times 10 to the negative 6.
0.000000776. That's equal to my concentration of H plus, right? Because I got out of my pH to get to my concentration of H plus. Yes? Yes? And now for the Ka, I have this. It's just going to be this squared divided by what? 0.250. You got it. So Ka is going to equal 0.0000076 squared over 0.250. And yes, that's going to be a small number.
Yes.
I'm not going to write out all these zeros.
That's a lot of zeros.
Is it,
Yes.
is it all those zeros 7-6 or 7-7-6?
5 zeros, 7 6.
Oh.
The first time.
The first one was 776.
No, that's wrong.
Okay.
Oh.
Sorry.
I think there were like a notation.
Wait.
that-
It isn't just.
I'll throw it back in the account.
Isn't it 7.76 times 7?
I thought it was 7. I think I might have.
10 to the negative 6.
That's
Somebody run that back.
7.76.
It's 10 to the negative 5.1.0000776.
I have scientific.
7.76.
776.
That is 776.
Yes.
So this should be 0.000000776.
776.
That's my bad.
Yes.
You could also use scientific notation.
Good.
But I decided to write zeros. I don't know why.
And then your answer is 0.00000.
I got 2.41
For what?
times 10 to the negative 10th. I got 2.41 times 10 to the negative 10th.
What an ugly inefficient notation. Should replace it with zeros.
Yeah. So moral of the story is use scientific notation.
No,
Yeah.
that was-
16.
That's 10.
there was 0.
There we go. Is that better?
Yeah.
Ooh, we can probably do one more. One more. KB.
Another one.
KB. So for KB, it's very similar, right? So let's do the general form, and then we'll call it a day. So for weak bases, very similar. So if I'm going to use NH3, let's write an equation for that. So NH3 is a weak base, AQ. I'm going to add this to what? Water, H2O, which is a liquid. That's going to be in equilibrium with NH4 plus AQ plus OH minus AQ. So the good news is, you know, for a base, you need to end it up with OH minus by itself on the other side, right? With an acid, you need to get H plus on the other side, or H3O plus. So be thinking through that. So here, that's my R. My I is going to be minus X plus X plus X. Change is going to be, oh wait, I'm sorry. My I is going to be X. X, 0, and 0. My change is going to be minus X plus X plus X. And E is once again going to be X minus X, X and X. This means that Kb is equal to the concentration of OH minus times the concentration of NH4 plus over what? Concentration of NH3. Or I could rewrite that as the concentration of OH minus what? Squared over the concentration of NH3, or x squared over concentration of NH3. There's lots of ways you could write it. And know that PKB is still equal to the negative log of KB. The negative log of KB. So, the major species. Let's get down to here and then we'll stop. The major species in solutions of all weak acids and bases will be their, this should say, THIER, will be their what form? What form will these weak acids or bases, what will the major species be? The undissociated form. They're
I didn't know that was a word.
undissociated form. I think it's a word. If it's not, add it to your spell check on your Chromebook. It is now. All right? They're undissociated form. Note, the higher the Ka, the stronger is the acid. Same for Kb. Or we could reverse it. And you could say, like Allison said, the lower the pKa, the stronger the acid. So far, none of this is super hard, all right? So far.
What do you mean so far?
pKa, the negative log of Ka.
There's too many Ks.
There's just, what?
The difference between
I don't
K
think we
and
get the
pH.
whole.
Wait, why is it if it's lower pKa?
So pH is based off the concentration of your hydrogen, right? Your pKa is coming from the Ka from your equilibrium equation. What? It's just a different version.
Is there any more Ks?
Wait, so if different temperatures than 298 K, where K sub W doesn't equal 1 times 10 to the negative 14, can the pH go to like 15?
It could. Yes.
Interesting.
Yeah,
My
it
dad
could.
texted me.
We won't.
He said